In this video, I'm going to show you how to make two Arduino talk to each other using serial communication and only two wires. I'm going to show you how to wire them and what the code you need to write to make them talk to each other. Let's get started. I will use two Arduino Nanos for this demonstration. You only have to connect them with two wires to make them talk to each other. The wires are connected to pin A4 and A5 on each Arduino. This is important because they will talk to each other using serial communications with the I2C protocol. And I will show you how easy it is to do it with a very simple program. Now in my demonstration, the Arduino on the left will be called Arduino A, and the one on the right will be called Arduino B. Here are the connections that we need to have between the two Nano. Pins A4 and A5 of both Nano are connected to each other, and you connect each Nano to a separate USB port on your computer. Note that the USB ports are only needed to upload the programs. We don't need them for the communications between the Arduinos. They will be able to communicate with each other only with the two wires connected to pin A4 and A5. You can also have two Arduino Uno and still follow me on this tutorial. The code will be exactly the same and the pins are also the same. A4 and A5 of each Uno are connected to each other. You can even have a combination of an Arduino Nano and an Uno. Again, pins A4 and A5 are connected to each other. Now, if you have another type of Arduino board, you must locate pins that support SDA and SCL interfaces. On the Mega and the Leonardo, these are pins 20 and 21. Here is my setup with two Nano that are connected to a USB port on my computer. Now let's get started with the code that we need to build so that they can talk to each other. Now first open your Arduino IDE and make sure you have an empty sketch, which is a setup and loop functions that are empty. And if you don't have an empty sketch, just go to File and select New Sketch and you will get an empty sketch. So we need to select the board. So in my case, I have a Nano board. And I'm going to select the COM5 port, hoping that it's this board, the A board that is connected to COM5, but we're going to check it to make sure. So click OK, and I'm going to save that sketch. And I'm going to call it Arduino A. Now go to my website, and I've put the link in the video description. So you go to this website, and we're going to download the library which is in the lib folder. And this library will make our life easier to program communication between the two Arduinos. So you click this button, choose download. It's going to download the file in your download folder. And go back to your Arduino IDE, choose sketch, show sketch folder, and move this file into your project file. Now, before using the library, I want to make sure that this sketch is going to upload code on the Arduino A, which is, I suppose, connected to COM5, but we're going to check it by making the built-in LED blinked. So I'm going here in the setup, use the pin mode function for the LED that is built in, define it as an output. And I'm going to write a function to make the LED blink. So the function will be called invert LED, and it will take as a parameter the pin number of a LED. So if we're going to read the LED, if the LED is I, so if the LED is turned on, we're going to turn it off. So digital write LED low, and else. So if the LED is actually turned off, we're going to turn it on. So I, and in the loop function, I'm going to call the function invert LED with the LED built-in LED parameter. So to make the built-in LED blinked, check the code. Perfect, upload it. And actually I have to here insert a delay so the blinking, we can see the blinking. So I will put alpha second. So we're going to see which one is the A board. So let's see. Not this one. And it's this one. So it's the B board. So what I have to do is just change my COM port. So I'm going to select the COM7 port, which will be a nano board also. And if I upload it again, so I'm going to see this one blink, and it's blinking. So my setup is correct. Now let's set up the library for the communication. So we have to include it, include communication. After that, we need to define the addresses of the board. So I will first define my address, which is this sketch, this board, and I will give it the address 10, and I will define the other Arduino, and I will call it other Arduino, and let's say 25. So you have to choose a number under 127, if I remember well. So you can choose any number you want as long as it is under 127. We need to initialize the library by calling its object. So let's define static communication, which is the name of the object in the library, and let's call it com. And we have to pass in the parameter the address of this sketch, of this Arduino. So my address. So Arduino A will be at address 10. And let's, in the setup, open the serial port. Begin 600 baud. Now we're going to write in the loop function and use the function of the communication library to get incoming messages, incoming communications that will come from the Arduino B. So let's get rid of that. So we're going to use a switch statement. And we're going to call the communication received function. And we're going to switch on the value that we received. So we can receive a string. So if it's a string message, we're going to do something with that. So let's first write the other case, which is we can receive an integer message. So we're going to receive just a number. So in the loop function, we're checking if we are receiving a message, and if it's a string message, let's say we're going to actually print on the serial port what we are receiving. So let's say let serial print, and we're going to get the string actually. So we're using again the com library, get string message, and what the function will do is actually return the string that was sent by the Arduino B. So let's now define the program for the Arduino B. So let's open a new sketch. And we will get an empty sketch. Let me resize that. And we're going to save it as Arduino B. So this time I'm going to select the other COM port. So it will be COM5 and it's still a nano board. Now go to the sketch menu, show sketch folder so that you can see where actually your file is for the Arduino B, and just copy paste the library that we saved in the Arduino A folder. So copy and paste. So make sure that you don't move it, but actually you're copying the library. So what we're going to do is simply cut and paste all of this code from the Arduino A sketch and copy it over by replacing everything like this. And the only thing that we need to change is the address. So this one is now address 25, and this one, the other Arduino, which is the Arduino A, will be at address 10. So make sure that you are actually inverting the addresses from both sketch. Now what we're going to do is this Arduino B will send a message to Arduino A. So in the setup function, we're going to use in the communication library the function transmit. And the first parameter is the address of the Arduino where we would want to send the message. So you have defined the address of the other Arduino, which is the Arduino A. And we're going to transmit a message. Let's say hello. And actually, let's upload the Arduino A sketch so that it is ready to receive the message. Let's open the serial monitor. And let's upload the code of the Arduino B. So what it's going to do is when it enters the setup function, it's going to transmit the message hello to Arduino A, which will receive it in the loop function and print it on the serial port. So let's upload it. And we receive the hello message from the Arduino B. Now let's send a number from the Arduino B to the Arduino A. First, we need to, when we receive a number, we need to print it to the serial monitor to make sure we have received it. So let's serial print. This time we don't get a string, but a number. So we're going to call the get it message and print it on the serial port. And in the setup function of Arduino B, we're going to transmit a number. So transmit to the other Arduino. Let's say we would transmit number 100. And first, let's upload the code of the Arduino A because we changed it to print the number. And let's re-upload the code from Arduino B to the Arduino B. So first, we're going to receive the hello message and the number 100. Now we're going to make the other Arduino A, send a message and a number to Arduino B. So first we must to update in our loop function. We must add the print number to the serial port. And we have to transmit. Let's copy that over to Arduino A. And let's say that we transmit from A to B I and the number 200. So first, let's upload the code of the Arduino B. And we're going to receive the LON100 to Arduino A. And let's upload this code, which will be sending to Arduino B the string I and the number 200. Like this. Now we are going to do something more useful in terms of communications between the two Arduinos. Arduino A will have a red LED connected to it, and Arduino B will have a blue LED. Using a switch connected to Arduino A, we are going to control the blue LED of Arduino B, and Arduino B will control the red LED on Arduino A, also through a switch. Here is the wiring. First, connect the ground pin of Arduino B to a ground rail on the breadboard. And to make connections easier, connect two ground rails on the breadboard together. Connect one side of the switch of Arduino A to the ground, and connect the other side to pin 7 on Arduino A. The ground pin of the red LED is connected to the ground rail on the breadboard. We add a 220 ohm resistor to the positive pin of the red LED, and the other side of the resistor is connected to pin 2 on Arduino A. We do the same thing for Arduino B. Connect one side of the switch of Arduino B to the ground, and connect the other side to pin 7 on Arduino B. The ground pin of the blue LED is connected to the ground rail on the breadboard. We add a 220 ohm resistor to the positive pin of the blue LED, and the other side of the resistor is connected to pin 2 on Arduino B. Now let's look at the code. Now here is my setup on the breadboard. So we're going to have this push button switch that is connected to Arduino A. When I press it, I'm going to make the blue LED of Arduino B turn on and off. And when I press this push button that is connected to Arduino B, I will make the red LED on Arduino A turn on and off. Now first, we're going to write the code in the Arduino A sketch. So I'm going first to define the LED. So I have LED connected to pin 2. And I will have the pin mode of that LED defined in the setup function as an output. And we're going to define what we need for the push button switch. So the push button switch is connected to pin 7. So we're going to define that. And we also need to define a value to debounce the switch. So let's say it will be 300 milliseconds. And we add a variable that will store the last time you read the switch. Like this. Now the next thing, we're going to actually write the function to read the switch. So it will return a boolean. So we'll call it switch pressed. Now we're going to read the value of the switch with the digital read function. So we're reading the push button. Now we make sure that first let's define the in the setup the pin mode for the switch. So the switch will be push button, and it will be an input pull-up. So meaning that, so input pull-up, we avoid putting a resistor for the switch. So we're using actually a resistor that is inside the Arduino. And what it does is when the switch is not pressed, we receive a I value, a 1, and when it is pressed, we receive a 0. So we make sure that we receive a 0 first in the function, because it means that the switch has been pressed. And next, we make sure that we debounce it. So we compare the last read switch with the debounce value. And if we are within the limits, it means that we actually read the switch. So we're going to first reset the last time we read it and return true, meaning the switch has been pressed. And in other case, we're going to return false. Let's verify the code. Debounce here. Problem. Spell the variable. Check again. Good. So first, let's define our command here. Let's say commands were defined. Let's say turn LED on, and we're going to define it as 100, and define another command to turn LED off, and let's say it's 200. Let's modify the code on Arduino B. First, we're going to copy over the definition that we just wrote in Arduino A file. So let's copy this, the definition of the LED, the Arduino B sketch, the commands and the push button definition. Let's copy that over here. And let's copy our function to read the push button. And what we're going to do in the loop function of Arduino B. So we want the blue LED of Arduino B to turn on or off when we receive a command, a message from the Arduino A. So we're going to receive a number. So it will be either 100 to turn the LED on or 200 to turn the LED off. Let's define a pin mode for our LED. So pin mode, LED, it's an output. And over here, when we receive a number, a command from Arduino A, so let's say it's a command that we receive. We're going to read the number. Let's copy that over. Receive a number. And get rid of that. And if the command is turn the LED on, we're going to use the digital write function of Arduino to the LED and send the I signal to turn it on. And if we receive the turn off command, turn LED off, we're going to send the low signal. Let's verify the code. Let's upload that. So it's ready to turn the blue LED on or off when we receive the message. What we're going to do in the Arduino A, so we have to detect if the push button of Arduino A has been pressed. So we're going to actually read if the switch has been pressed, and if it has, let's say we're going to send the message to Arduino B, transmit. First, I have to put the address, so it will be the other Arduino. Let's copy that over. And we're going to transmit the turn LED on command. Verify the code. Let's upload it. Let's try it. So if I push the button on Arduino A, it will send a command to Arduino B to turn the blue LED on. Now, when we press the switch again, we want the LED, the blue LED, to be turned off. So in order to do that, instead of sending a low signal, what we're going to do actually is reuse the invert LED function. So we will create a new command that is called invert LED. And let's say it's command number 50. So let's copy that over to the Arduino B sketch. So what we're going to do is, if we receive the command in Arduino B, invert LED, we're going to call the invert LED function. So what it does is, if it's turned on, the LED will be turned off, and if it's off, it will be turned on. So now we need to send from the Arduino A. When we press the switch, we're going to send the invert LED command. Let's upload the code to Arduino A. Upload the code to Arduino B. Now we're ready to go. Now if I press the switch, it's turned on. Press it again, it's turned off. Now the last thing is that we implement the same function for the Arduino B. So when I press this switch, it's going to turn the LED, the red LED, on or off on the Arduino A. So we have to copy over this section of the code when we receive a number, a command, and put it in the loop. And it's going to do the exact same thing. Let's see if now I have to copy the when we read the switch on the Arduino B. That. So we're going to send the invert LED command. And let's not forget to actually initialize the switch on the Arduino B. So we have to define the pin mode for the switch. So now let's upload the code to the to Arduino. Done. Now if I press the push button switch that is connected to the Arduino B. It's going to turn the red LED on and off. Same thing for the other switch. Now we have completed programming the communication between the two Arduino, and you can get the code on my website. The link is in the video description. You can get the code for the library, the sketch for Arduino A, and also the sketch for Arduino B. Now I'm going to show you my actual use case for having two Arduino communicate to each other. I've made this prototype board to help me program the two Arduinos. And at the end, it will be a kind of sci-fi panel that I'm going to make. So on this side of the board, there is a small OLED display, and it is controlled by an Arduino. And on the other side of the board, I have another Arduino controlling the LEDs at the top and the switches. So this Arduino on that side will be sending command to this one to act on the OLED display. Let's look at the back of the panel. So here you have one Arduino controlling the mini OLED display, and this one is controlling the switches and the LEDs on the right side of the panel. So the way it works is when I have some combination of position on the switches, it will send command to this Arduino. So for example, this combination is turning on the display, the tactical display that is showing on this side. And when I have this combination, it's turning off the display. Thanks for watching, guys, and check out my other videos on my channel on tutorials for programming for the Arduino, and I have some videos on how I build my sci-fi props. Subscribe to the channel and don't hesitate to leave a comment.